Alright, we have another physics problem from electromagnetism here. I don't know if you're following all my videos. I'm pretty much going through most of the evens and some of the odds and the problems in the first chapter of electromagnetism for physics. Just covering what to me seems like what teachers would normally subscribe in a class. So this question is going to be here. I'm going to read it out, and it's going to be in the actual problem will be in the description below the video. This is a pretty easy problem. It's pretty intuitive, but because there's no numbers involved, it's all variables, then sometimes it tricks people up, so I thought I would do it. And okay, so the question is three identical point charges Q are placed at each end of three corners of a square. Okay, so of a square of side length L, find the magnitude and direction of the net force on a point charge -3Q placed at the center of the square, and part B at the vacant corner of the square. In each case, draw a free body diagram showing the forces exerted on the -3Q charge by each of the other three charges. Okay, so we're going to be using Coulomb's law to calculate the forces between the pairs of charges and sum these forces as vectors, and we need to find the net change. So for part A, first we're going to need to do a sketch for this. So let me draw an imperfect square. Okay. Alright, so we have our square here, and we know that this is of length L, because that was given to us, so that's length L. And we've got a charge Q1 here. Well, they're all the same, so we'll just call them Q. Charge at each three corners. And then we have a charge of -3Q directly in the center. Okay, and so this is going to be, okay, so let's look. We need to find the radius. We'll need to find the radius for each point from here outward. So the radius, you should be able to figure the radius out fairly easy using Pythagorean theorem. What you would do here is you would divide this right here, make it a 90-degree angle, and we know that, so we've got L over 2 and L over 2 for two of the sides, so we'll get the radius to be equal to the square root of L over 2 squared plus L over 2 squared, and that's going to be equal to, let's see, R is going to be equal to L squared over 4 plus L squared over 4, and that equals 2L squared over 4, and again is going to equal L over the square root of 2. Okay, so there's our radius. And this here, let's label this some more. This is going to be force 1, force 2, force 3. Okay, and so this isn't too difficult. I mean, we've got our radius now, and well, we stated before we're going to use Coulomb's law, right? So we're going to have force is equal to 1 divided by 4 pi epsilon naught multiplied by Q, 3Q over the length divided by the square root of 2 squared, And I'm just going to point something out here. You know, I don't know if you notice in a lot of my videos I actually write out 1 over 4 pi epsilon naught instead of the k variable. And the reason I do that, usually in the beginning equation, later on in the equation I'll probably change it to k. But in the beginning of the equation, when we're putting things together, sometimes you'll get a 2 in here, and it just, you know, it just reduces down, just for reducing down. You know, not too big of a deal. I mean, maybe it's easier just to leave the 2 in there and still use that as k. You know, but if you're rearranging things, sometimes it's easier. You know, so. But you know, just thought I'd point that out. If anybody was, sometimes people are like, why are you writing all that out when it's not necessary? And sometimes it is necessary. So, all right. So this is going to equal. Let's see. After doing all the math and everything on it, I'm assuming you can do basic algebra if you're taking calculus-based physics. So this is going to be 6q squared over 4 pi epsilon naught times the length squared. Okay. And so that is the force here, and let's see, we got to find the magnitude and direction of it. So this is the force on Q. Okay, so all right, and this is going to be away. If you were asked the direction, a good way to state this would be it's moving away from the vacant corner. I'm just going to say away from free corner. I guess free, I don't know, vacant. So we're moving away from this corner here. So, all right. Now we need to do part B. So that was part A. Part B. Part B is the same question, except for we moved negative 3q down here. So I'm going to use the same. Same deal here, and I'm just going to work with a different colored pen here. And so this is now Q3, negative 3Q, and we've got our forces again. And so this force here would be your F1. This is your F1 on 3, and then this is your F3 down here, and then there's also another one right here, that's your F2, and then we've got everything else is already written for us up here. And okay, so let's think here about what we're going to do. So we need to find the radius of this, and well, the radius should be pretty simple to figure out. You can do L squared plus L squared, so you'll get 2L squared, because the length is L and we've got a right angle here, so let's just write that out. So the radius is going to be the square root of L squared plus L squared. And that's the radius from Q1 to Q3 now. So the radius from 1 to 3 is L squared plus L squared, so that equals the square root. That's 2L squared, so the square root of 2 times L. And so that's the radius from here to here. And then we know our radius from here to here and here to there is going to be L. So we'll just call that radius 1 and 2 is going to equal L. So this charge here, or force here and force here, is going to be the same because of the same distance, and these are equal charges. So okay, so now let's do force 2 first here, the one here in the center. And force 2 is going to equal, let's see, since we don't need to do any, well, let's see, 1 over 4 pi epsilon naught, and same thing, we got Q times, it's basically the same thing we just did, times 3Q. Remember, we always take the magnitude of these charges here, So let me write the original equation. Force equals K times the magnitude of Q times Q prime over R squared. So we're always taking the magnitude. If you're just wondering what happened to the negative sign, you should know that by now, but just pointing that out in case. And this is going to be square root of 2 times L squared for our radius. And so that equals 3Q squared over 4 pi epsilon naught times 2L squared. And okay, so that's force 2. And now force 1 and equals force, this force here equals force 2 or 3. I guess this is 3, so we'll call that force 3. So force 1 and 3, this will be force 1 and force 3 over here. Those equal each other. And we end up with 4 pi epsilon naught times Q, 3Q again, over L squared. And that equals 3Q squared over 4 pi epsilon naught L squared. And now, if you recall here that we'll need to do the vector sum in order to find the magnitude in this case. And so, let's get another sheet of paper here. Okay, so force 1 for the vector sums of F1 and F3. For the vector sums of F1 and F3, we're going to get F13 equals the square root of F1 squared plus F3 squared. And the reason why, now if you're wondering why I'm just choosing both of those, well, this here is, for this one, we have a 0 degree angle and a 90 degree angle, so this is our x and our y, because one of them is going to be 1 and one of them is going to be 0. So that's how you know angles. So that's trigonometry. That should be pretty intuitive to you at this time in your career, your educational career. So, all right. So now let's look at force 1 and 3. That's going to be also equal here to the square root of 2 times force 1. And since we have force 1, we're going to get 3 square root of 2 times q squared divided by 4 pi epsilon naught L squared. And that tells us that F1 and 3, 1 on 3, and I should be putting vectors on all these, by the way. F1, 1, 3, and F2 are in the same direction. Okay, and so now we just need to find our total force, and so that's going to equal force 1 of 3 plus force 2, and so that gives us 3q squared over 4 pi epsilon naught L squared times the square root of 2 plus 1/2, and that is directed towards the center. So towards center. Okay, so a little summary. By symmetry, the net force is along the diagonal of the square, and the net force is only slightly larger when the negative 3q charge is at the center. Here it is closer to the charge at point 2, but by the other two forces cancel. So that is why it's moving towards the center. Okay. And always remember that if you subscribe to my channel, you can submit me a problem, and if you can't find it on my channel, that is, and I'll do it for you and submit a video. Thank you.